In this video, we will understand what is a radian measure. We know that the circumference of the circle is given by the formula 2 pi r units. If r is the radius of the circle and the circumference of the circle is defined by 2 times pi into r. So, extending this to measuring this angle theta in relation to the length of the arc here is called the radian measure. So, this length will be related to the radius. If we allow theta to take a full circle in the circle, then theta's value will be 360 degrees. So, a full circle in terms of degree would be 360. Similarly, the full length of this circumference of the circle is given as 2 pi r. So, we equal the 360 degree to the 2 pi r, and we define each length, arc length, which is equal to the radius as 1 radian. Therefore, 1 radian measure is nothing but the length of this arc here, which is equal to 1 radius. So, now the degree measure is called 1 radian. Let's assume an angle theta, and let's assume that this length here is equal to s. Then this angle in measure of radian would be nothing but s divided by this r, which is the radius. So, in other words, the angle theta in radians, which is marked by the c here, is equal to s, which is this length here, arc length, divided by r, which is the radius of the circle, and is defined as radians. Further, we know that 2 pi radians is equal to 360 degrees, which is 360 degrees is one full circle here. So, the angle 360 degrees is equal to the length here, which is 2 pi radians. Therefore, we can further reduce it by dividing both sides by 2. Pi radians is equal to 360 divided by 2 will be 180. In other words, 180 degrees is like the semicircle. So, the angle of the semicircle would be pi radians, or we can call it as 180 degrees. So, to convert the radian to degree and from degree to radian, we can say that 1 radian is equal to 180 divided by pi degrees, or we can also say that 1 degree is equal to pi by 180 radians. Further, we can extend it. If we are given x radian, then to convert the radian to degree, all you have to do is multiply the x with 180 and divide it by pi. You will get the corresponding degree value of it. Or if you're given the degree and you want to convert it to radian, then if you will multiply the x into pi and divide it by 180, then you will get the corresponding radian. You can treat this as the conversion formula for radian to degree and from degree to radians. If the unit of angle measure is not specified, then the angle is understood to be radians. So, if you don't see the degree or any symbol, then it is understood that it is represented in radians. Consider a sector of a circle with radius r. If theta is the central angle of the sector, then the area of the sector is given by the formula pi r squared by 360 into theta in degree measure and pi r squared by 2 pi into theta, which is equal to r squared into theta by 2 in radian measure. So this is when you are asked to find area of a sector of the circle. Clearly, the calculation of the radian measure is much easier to work with. This is very evident from these two formulae. The values of pi and 22 by 7, the ratio 22 by 7, correct to 4 decimal places are 3.1416 and 3.1429 respectively, which is for pi it is 3.1416 and for 22 by 7 the value is 3.1429. Thus, pi and 22 by 7 are approximately equal, correct up to 2 decimal places. Hence, pi is almost equal to 22 by 7. Further, we can define 1 radian as 57 degrees, 17 minutes and 45 seconds. So, 1 degree is almost equal to 0.017453 radian, and 1 minute is equal to pi by 180 into 60 radian, which is almost equal to 0.000291 radian, and 1 second is equal to pi divided by 180 into 60 radian, which is equal to 0.000005 radian. The radian measure and the corresponding degree measure for some known angles are given in the following table. So, the radian of 0 radians is equal to 0 degrees. 1 radian is equal to 57 degrees, 17 minutes and 45 seconds. And 0.017453 radians is equal to 1 degree. Also, pi by 6 radian is 30 degrees. Pi by 4 radian is 45 degrees. Pi by 3 radian is 60 degrees. Pi by 2 radian is 90 degrees. Pi radian is 180 degrees. 3 pi by 2 radian is 270 degrees. 2 pi radian is 360 degrees. Let's work out example 3.4. Convert 18 degrees to radians. We know that 180 degrees is equal to pi radians. Therefore, 1 degree is equal to pi by 180 radians. Okay, so the first question is 18 degrees. So 18 degrees will be equal to pi by 180 into 18 radians, and that's equal to pi by 10 radians. Question number 2. Minus 108 degree will be equal to, using the same method, pi by 180 into minus 108 radians, and that's equal to minus 3 pi by 5 radians. Example 3.5. Convert pi by 5 radians to degrees, which is the first one. So, we know that pi radians is equal to 180 degrees. Therefore, pi by 5 radians will be equal to 180 divided by 5 degrees, which is equal to 36 degree. Similarly, the second one, 6 radians will be equal to 180 divided by pi into 6 degrees, which is 7 times 180 divided by 22, using the value of pi as 22 by 7 into 6 degrees, and that's equal to, simplifying this, we can get 343 7 by 11 degrees. Example 3.6. Find the length of an arc of a circle of radius 5 cm subtending a central angle measuring 15 degrees. So the angle here is given to be 15 degrees and the radius is given as 5 centimeters. So we are asked to find this length of the arc. Now, okay, let's define S be the length of the arc of a circle of radius r is equal to 5 centimeter subtending a central angle theta which is equal to 15 degrees. Then we have our theta is equal to 15 degrees. So this, to convert it into radians, will be equal to 15 into pi by 180, which is equal to pi by 12 radians. And our S is equal to or theta, where theta is given in radians. So our S is now equal to, R is 5 and our theta is pi by 2. So the answer is 5 pi by, this is 12, 5 pi by 12 centimeter. Example 3.7. If the arcs of same length in two circles subtend central angles 30 degrees and 80 degrees, find the ratio of their radii. So you're given two circles and the arc here, which subtends 30 degrees, is equal to the arc length here, which subtends 80 degrees. So we need to find the ratio of their radii, which is R1 by R2, or R1 is to R2. Okay, so let R1 and R2 be the radii. Okay, then let theta 1 be equal to 30 degrees. So this will be 30 degrees, we know, is pi by 6 radians. Theta 2 is equal to 80 degrees, and that's equal to 4 pi by 9 radians. So given to us, so it's given that the length L of the first one, which would be nothing but the ratio of R1 into theta 1, is equal to the ratio of R2 into, which is this length here, theta 2. So substituting the values of theta into this, we can say pi by 6 R1 is equal to theta 2 is 4 pi by 9 R2. So further simplifying, we can cancel the thetas, and rearranging, we get the answer as R1 divided by R2 is equal to 8 by 3. Therefore, the ratio R1 is to R2 is equal to 8 is to 3.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.